Today our lesson is on exponents. You're going to want to set up your paper in Cornell Notes style. Make sure your name and the date is at the top right hand corner. Our topic is exponents, and our objective is to learn how to identify exponents, what they mean, and how to simplify them. So let's start with 4 times 4 times 4 times 4 times 4. That's a lot of 4s to write. Exponents help us write this exact same thing in a much easier way. And so that's what exponents are. That's what they mean. Exponents are an easier way to write repeated multiplication. Exponents are an easier way to write repeated multiplication. So an easier way to write 4 times 4 times 4 times 4 times 4 is 4 to the 5th power, where 4 is called the base, and the 5, that power of 5, is your exponent. And what that means is you're going to take the number 4 and multiply it by itself 5 times. So the exponent tells you how many times to multiply a number by itself. The way that this is written right here, the 4 times 4 times 4 times 4 times 4, is called expanded notation. So with Cornell Notes, remember, you take all your notes and then you write yourself a question. So a question for this would be, how do I write 4 to the 5th power in expanded notation? And so remember, your paper will fold over just like this. How do I write 4 to the 5th in expanded notation? 4 times 4 times 4 times 4 times 4, and then you'll be able to check your answer. So what is expanded notation? It's showing the multiplication and the expanded way of what 4 to the 5th power is. So I want you to have 3 columns: exponential notation, expanded notation, and then simplified. Simplified means to come up with an answer. Okay, so 4 to the 5th power, if we wanted to write that in simplified form, 4 times 4 is 16, 4 times 4 is 16, 16 times 16 is 256, and 256 times 4, if you wanted to pause the video so that you could figure it out on your own, 4 to the 5th power would equal 1024. So we have 4 times 4 times 4 times 4 times 4. Obviously, 4 is the base, and then the exponent told us how many times we wrote it to the 5th power, and then simplified 1024. Well, what about this one? 2 times 2 times 2 times 2 times 2 times 2 times 2. Again, remember, you can pause the video at any time so that you can catch up or keep up. So the base is 2 because that's the number that's being multiplied repeatedly. And how many of them have been multiplied? 1, 2, 3, 4, 5, 6, 7. So this would be 2 to the 7th power. And then simplified means find an answer. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. So now you've seen some examples, and now we're going to look at it algebra-wise. N times n times n times n. N stands for any number. So what is your base? The base will be n. And then what is the exponent? Exponent should be 4 because there are 4 n's. And we can't simplify because we don't know what the n is. So at this point we would come up with a question. A good question would be, How do you write n times n times n times n in exponential notation? And there you would have your answer. Now there are some special exponents. Exponents of 3 have a special name. They are called cubed. So if you see this, you say b cubed. Or if you see this, that's 16 cubed. And when we get to geometry, that'll make more sense. Exponents of 2 are called squared. So if you see this, that is pronounced x squared. So exponents of 3 are very special, and exponents of 2 are very special. Exponents of 3 are called cubed. Exponents of 2 are called squared. So a good question would be, what are 2 special labeled or specially labeled exponents? Okay, so if you'll go ahead and write on your paper, exponential notation for 3 to the 5th, 3 to the 4th, 3 cubed, 3 squared, 3 to the 1st, and 3 to the 0 power, which are looking at this and saying, man, I didn't even know we could do that. You can. So 3 times 3 times 3 times 3 times 3, what format is this? If this is exponential, what format is this? Expanded. And then we're going to do our simplified version over here. So 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. And 81 times 3 is 243. 3 to the 4th power. And if you'd like, you can pause the video and fill out what you can. Replay the video and check your answers. So what I'd like for you to notice is that exponentially, our exponents are decreasing by 1. So we went from 5 to 4, 4 to 3, and so on and so forth. But I want you to take a look at what happened here in the middle. We dropped a 3 each time. But what did that do to our answers? Dropping a 3, what did that do? To get from 243 to 81, we had to divide by 3. To get from 81 to 27, we had to divide by 3. To get from 27 to 9, we had to divide by 3. To get from 9 to 3, we had to divide by 3. Why is it all divide by 3? That is your base. So 3 squared was 9. To get to 3 to the 1st power, we had to divide by 3. So 3 to the 1st power is 3. What will be 3 to the 0 power? Our pattern says divide by 3. So 3 divided by 3 is 1. That's important. So 3 to the 1st power. What is 3 to the 1st power? 3 to the 1st power is 3. And then what is 3 to the 0 power? 3 to the 0 power is 1. So let's take a look at what happens with 2's. Again, 2 to the 5th, 2 to the 4th, 2 cubed, 2 squared, 2 to the 1st, and 2 to the 0 power. So we decrease by a 2 each time. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. This is our exponential notation, expanded notation, simplified. How do you get from 32 to 16? You divide by 2. How do you get from 16 to 8? Divide by 2. 8 to 4? divide by 2. 4 to 2, divide by 2. So 2 to the 0 power, if we hold true to our pattern, 2 to the 0 power is going to be 2 divided by 2, which equals 1. Hold up, wait a minute. 3 to the 0 power was 1, and 2 to the 0 power is 1. So what does that mean for any number to the 0 power? Any number to the 0 power is, in fact, 1 all the time. But what about any number to the first power? 3 to the first power was 3. 2 to the first power was 2. So any number to the first power is that number. So here's another example. 123 to the first power is going to equal 123. But 123 to the 0 power is just 1. So now, after you finish taking your notes, you should write a summary. Remember, a summary has a beginning, a middle, and an end. And what I'm going to do is I'm going to get you started and let you fill in the rest. And tomorrow when you come into class, we'll exchange notes and you can share with a partner how you filled in the blank. So to get you started, an exponent is an exponent tells, I'm going to pull it up on a different screen for you, make it a little bit easier for you to see. Let's do it just like that. An exponent is blank. The exponent tells exponents of 1 equal exponents of 0, and you can feel free to put the word always in there. Exponents of 0 always equal something. And then I've provided a couple of examples for you to try. And that is the end of your first flip lesson on exponents, exponential notation, expanded notation, and simplifying means to solve.